be looking at various ways in which you could deploy things, and we would be doing that as well. So what you wouldn't have is something like, let's say, start from a programming language and you stick to that. You would use a web framework, deploy something, and then host that in GCP. So we wouldn't be doing that. And, to whom is this intended to? So people who are new to cloud, people who are new to GCP itself, or folks who are like interested towards cloud. So this is, I mean, you people are the ideal folks to attend this workshop. So it's 3 hours. So what I have planned is that let's look at the theoretical aspects for some time, about 30 minutes, so that you can't actually get into the actual platform itself without knowing what it is, right? So we'll spend some time looking into those, and I understand that we don't want to get too much into the theory of things, so I'll keep it short. So let's begin. Yeah, a little about myself. I'm working as a cloud technical solutions engineer at Google. I am part of the cloud platform team. I take care of solutions like the Google App Engine, Cloud Run, Cloud Functions, and a few more. So yeah, let's begin. So what exactly is cloud? So if anyone wants to go on mute yourself and just give me what you think about cloud is, please go ahead. I'll just give it a couple of seconds if anyone wants to do that.
You
Right.
said that's informally
Yeah.
a virtualized data center?
Yes, almost right. Anybody else? All right. So what cloud exactly is that it's the delivery of services. It might be compute services, it might be storage, it might be software itself to customers on demand. So if let's say let's say I want something, I want a computer somewhere, or I want some storage, or I want some software for a particular duration of time, and I want it right now, I should be able to get it. And that exactly is cloud. Cloud service providers provide that service to the customers. So when you look at things, you usually have three types of offerings when you look at cloud. The first one would be the infrastructure as a service. The next would be the platform as a service, and the other one is the software as a service. So to begin with, if you look at the infrastructure as a service, this is nothing but your hardware itself. So we will talk about virtualization later. So let's talk about these layers itself. So you have networking, storage, servers, and your virtualization, right? So till these servers, it's all your data centers. Upon that, you have a virtualized environment, which the cloud service provider provides it to you. After that, whatever you have in black, right, this is managed by you. So let's say your operating system, any middleware that you might have, your runtime data and applications, right? All of these things are managed by you. So if I have to say, let's say I want a machine of, let's say, 4 CPUs, and I want a RAM of let's say 16 or 32 GB, and I want storage of 300 GB. Might be a hard disk or might be an SSD. I should be able to configure that on my own, and just on a couple of clicks, I should be able to get that in a couple of seconds. So that is this infrastructure as a service offering. And the next part that you get towards is the platform as a service. I'm a part of this team, and what we offer here is that let's say developers, right? They don't want to take care of all of the backend infrastructure. They don't want to specify and maintain the servers. All they want to do is they want to develop and deploy their applications. In such cases, in platform as a service offering, up till your runtime, it is managed by the cloud provider, and you only manage your data and applications. What this means is that you don't actually specify how many CPUs you want or what RAM you want. You just specify that, okay, this is my runtime. Let's say I'm running a Python application or a Node.js application. You specify what that is, and you specify how it's supposed to run, and you just leave it there. You deploy it. Your cloud service provider takes care of your scaling. So if you're getting too many requests and your instance is not able to handle that, your provider itself would scale, let's say, your application. Might be a virtual machine or a container, and all you have to do is deploy that. And deploying would also be a single line command. So I have to give an example of App Engine itself. You just go to your project folder in your machine, in your local computer, and you just type in one command and it's deployed. So this is the flexibility that the platform as a service provides. What is software as a service? Software is basically up to the application. Everything is managed by your cloud provider. So I think giving an example would probably make you understand better. It could be, let's say, your Google Docs or Google Sheets or even Gmail, to be specific. So all of these things, you don't know where this is running, right? You don't know which region it's running, or what computer it's running on, how much RAM is being used, or what storage, what type of storage, or you wouldn't even know what kind of backend it's using, or any of the architectural aspects, right? You just go, you just use the software and you're done. So this is the software as a service offering. So coming to Google Cloud Platform itself, what exactly is the Google Cloud Platform? So cloud is a technology, right? And you would want some service provider to provide it. So Google Cloud Platform is one such provider. So we provide a couple of services to the customers. So talking about what services we do provide, this is the list. So we provide services from compute, storage, databases, data analytics, AI, your developer tools, networking tools, tools for your G Suite, and etc. So looking at this looks like a big list, right? And yeah, a few times it seems scary, but we don't really care about all of these products. I mean, you don't use all of them, in your day-to-day activities. You only have to concentrate on a few things, and those are your compute and your data. So compute is where you actually run your applications. It's the processing power that you get. So there are a couple of options that you would get on GCP for compute, and we'll go through them when we go to the hands-on. But this is where you actually compute things. And next is your data. So I think, yeah, data is a new gold, right? So it's always good to have data, but what's better is what you can do with that data. You could organize your data and run applications, run services on that data to get some insights, and that becomes your data analytics, right? And you could use that data for, let's say, your ML training and stuff to build good models. So let's look at our compute itself. So in Google Cloud, we have a couple of your compute offerings. We have like the compute engine itself, then we have the serverless offerings. So on my left-hand side, it gets more complex. So we start with your virtual machines. So your compute engine is where you actually design your virtual machines, where you request for a virtual machine and you get a virtual machine. If you go towards the right, so you go towards your platform as a service, where you have these serverless options. So we have App Engine, we have Cloud Run, and App Engine is basically a PaaS offering where you don't take care of the infrastructure, you just deploy applications. And Cloud Run is one such offering where, if you've heard about Docker containers, so it's a platform where you just take a Docker image and deploy them as containers. Moving towards the right, we have Cloud Functions. This is a function as a service. So what this is that you don't take care of anything. You don't do anything here. You just write a function, and that function responds to a trigger. Let's say an HTTP request, and whatever you write in the function, right, that will be returned back. So we have a couple of options there as well. You could use Python, you could use PHP, you could use, let's say, JavaScript, and so on. So the advantages and disadvantages here. If you move towards the left, the complexity is higher. The time and the effort required to actually design your solution, right? From, let's say, your virtual machines, you will have to plan how many virtual machines you would need, and what OS you would run, and how you would configure it, your architecture. I mean, what servers you would run, what applications you would configure within that, and how you maintain it becomes harder. But the advantage here is that you get complete flexibility. You could do everything that you get, SSH access to your machine itself, and you could perform whatever you want in your machine. So that is the advantage. Coming towards the right, complexity is very low. So you could write a function on your browser itself and deploy it. So it's that simple. But what you cannot do here is that because it's fully managed by the provider itself, you don't have the flexibility of installing whatever you want. So if it's a machine and you want to run some custom runtimes there, you won't be able to do that. Moving on. Yeah, this um, explains let's say the different types of solutions that we have. Not just Google Cloud has the different architectures that we usually look at. So back then, right, a couple of years back, you would have this bare metal server. So what this means is that you would have your hardware, right? Let's say it might be an enterprise or it might be a single computer. You would have your hardware, you would have an operating system, might it be Linux or Windows. On top of that, you would have dependencies. Let's say, what example do I give? If it's Python, you might need, if it's a web application, you might need a Flask server, or let's say Django. If it's Node, you might need Express.js or any of the Node modules. Or yeah, if it's like a generic server itself, you might need a reverse proxy like Apache or Nginx. So all of those things fall into the dependencies and the application code itself. So all of this, is just one, box here. If you move towards the virtual machine side of things, you would have your hardware. On top of your hardware, you would have something called as an hypervisor. That's your virtual machine engine. On top of that, you would have all of these things: the thing in the box, your operating system, your dependencies, and your application code. So what your virtual machine engine, right, which is your hypervisor, does is that it will virtualize your hardware. So physically you would have a different set of RAM and CPU and other resources. Virtually you would have different ones. So let's say if you have a 4-core machine with 16 GB of RAM, running just one application there might not make sense. And if you run multiple applications on the same thing, you will not have isolation between these applications. So you would want an environment where it is isolated from everything else, but you want to get the resource from your physical machines. So what your hypervisor does is that it virtualizes that. So your 4 cores could be virtualized into two cores, so two virtual machines there. So you would have two of these boxes on your hardware. And yeah, advantages of this, you get like isolation for your application. So let's say one of your applications screws up on the let's say the OS level itself. So it will not affect your other application because these are two different virtual machines itself. So yeah, because of this isolation, virtual machines came into existence, and mainly for better utilization of resources. So in cloud, if you have a data center, you would run a couple of software on top of that, but on that you would have a virtualizing software. So it will virtualize things, and you have a couple of machines, it will virtualize all of that. And when you request for, let's say, 2 or 3 cores or 4 cores of machine, it'll give that to you. It'll virtualize and it'll give that to you. Moving towards a container. So I mean, for example, you have Docker here. So what this does is that the disadvantage of virtual machines was that even though you virtualize things, even though you've put an hypervisor, when you have a virtual machine, you would have to install an operating system on that. So your virtualization starts from your operating system. If you see the yellow box here. So for each of your applications, when you have to keep them in virtual machines, you would have to have one operating system there, and then all your dependencies and everything else. So even in virtualization, you have two types. You could have, let's say, an operating system running on your hardware directly, and after that, you could have a hypervisor. For example, if you're using Windows, you could install a VirtualBox, and it runs as a software to Windows, but within your VirtualBox software, right? You could have different virtual machines. So disadvantages here is that you're running a host operating system, which might be Windows, and on top of that, you're running another virtual machine with another guest operating system running on that. So it becomes a waste of resources if all your intent is just to run an application. So that's where these containers come in. What you do here is that on top of your operating system, you have a containerizing engine. So it might be a Docker engine, for an example, and your kernel, right, your Linux kernel, which is just a part of your operating system, it's shared. So you can have multiple containers, using the same operating system, and it's isolated from each other. So advantages of this, since this is not dependent on your operating system, you can build cross-platform solutions. So you could build something which runs on Linux, Mac, it runs on Windows at the same time. So it becomes easier to package and share them. So this is what is one of the advantages of containers. The other would be, let's say, sharing them, right? So we won't be going in depth towards Dockers or containers. So just to give a small, summary of things with containers. If you've used like version controlling systems like Git or GitHub and stuff, so containers also, let's say Docker has Docker Hub. So here you just do not just commit your code. You commit an image. So an image is a current state of your application. It contains all of your dependencies. It contains your code. So let's say I commit an image of an application. I push it to Docker Hub. Anybody who's pulling it from Docker Hub will be able to run it the same way that I intended it to be. So they don't have to do any other setup. They would just have to have the Docker engine with them, and they'll be able to run it. So that's the flexibility that your container gives to you. Coming towards the platform itself, here we just deal with the application code. If I have to give an example, we could look at the app engine itself. As I've told you before, you would not take care of any of your backend servers. So you would not, let's say, configure any of your virtual machines, or let's say what type of storage or the networking or any of that aspect. You just write your application. It might be a node application, or it might be a Python application, and you just deploy that, and it'll be deployed, and it'll be scaled based on what you want it to scale towards. So you could put like a lower limit and a higher limit on how it should scale, and it'll scale it depending on the number of requests that comes in. And one other advantage in this situation, talking about App Engine itself, in the standard type of things, your container scales down to 0. So if there's no requests coming in, you won't be charged at all, because there won't be any instances of your application code running. So only when the request comes in, let's say your app engine spins up containers to serve that, and that happens within a fraction of a second. So you won't have let's say a lag when you want to check things out. And coming towards the function itself, right? So here you don't manage anything, you just write a function. So you're given a template for a particular language that you select, and you write that function, and that is triggered based on a couple of things. It might be an HTTP request, so you'll be given an endpoint, and if you trigger that, if you just visit that on your browser, or if you visit that from any of the other application code, if you send a GET request, that function will be triggered, and whatever you return from that function would be sent as a response. So that's like simplifying a lot of things. So here, you're not actually designing a package solution. You're running this on a function level. So you design an application in such a way that you do most of the things in front end, and the things that you want to do in the back end, you just design them as functions, and you put them on the cloud functions aspect. So data on GCP. So when you look at data itself, right, you might have files, you might have databases, or you might have like big data itself, huge chunks of data. So we have solutions for all of these things. So let's talk about files itself, right? So we have something called as cloud storage. So this is where you store your files. Cloud storage is simply an object storage solution. So any object, might be anything. It could be images or videos, or let's say your HTML files or any JavaScript files. Any objects could be stored here. So the good thing about it is that you don't have any limits. There is no limit at all to how much data you could store in the cloud storage. But there is one limit, which is your individual file, right? The maximum size of an individual file could not be more than 5 terabytes. So that is one limit. But yeah, if you have file size greater than 5 terabytes, you can split that into 2 files and store them. So that is your cloud storage. And your application data, right? So not everything could be written down into files. So you would have to interact with other services and keep your data there. It might be in the form of your SQL databases, or it might be in your NoSQL. So you could have something like a JSON, a representation of things. You would want to keep them as documents, or you might want to have a relational database itself. So we have those solutions as well. So looking towards the SQL part of things, your standard, let's say MySQL or PostgreSQL SQL server, you could spin them up with Cloud SQL. So this is again a managed service. So Google takes care of, let's say, creating this instance, managing this instance, and its maintenance. So whenever there's an update, or let's say a security vulnerability, Google will patch that up. And let's say if you want to scale it up, if you want to, let's say, have replicas of the same database, it might be read replicas, or if you want high availability, so it will spin up another instance of this in the case of failover. So even if one of Google's data centers goes down, if there's a huge fire there, your application will not have a downtime because you have high availability. Request to be routed to your failover instance. So that is with respect to SQL. And with respect to Cloud Spanner is uh, also a relational database system, but it's for huge data. So if you have like data sizes, I mean, size of the data that you want to put into your database greater than 10 terabytes, so you could use a Cloud Spanner. So here you would have, let's say, a couple of nodes. You could scale them horizontally. You could, whenever you have more requests, you could just add a couple of nodes into your cluster itself, and your Cloud Spanner would use those nodes to respond back to you. So that is the Cloud Spanner. Talking about NoSQL, we have three solutions. All of them are quite similar. So your Cloud Data Store, Cloud Firestore are document databases. So you could store your JSON documents there. So they have a couple of differences, but they're pretty much the same. They store your documents, and they're organized in different ways between them. One organizes them as collections, and the other one does it in a different way. Coming down to your Bigtable is your column database. So again, this runs on nodes, so you can add as many nodes as you want based on the request that is coming in, and you get close to 10,000 operations per node. So yeah, Bigtable becomes your, I mean, it's basically a spanner for your NoSQL data. Coming towards your BigQuery. BigQuery is a data warehouse. So if you have like tremendous amount of data and you just want to store it somewhere, and let's say at a later point, if you want to query something, get some insights out of that, that's where your BigQuery comes into picture. You could have solutions like, let's say, data that might not be very significant, but you want to store that to generate some insights on the later stage. Might be some financial transaction data, or might be something to do with, let's say, alerts or notifications, or something to do with, let's say, IoT aspects. So all of these things, you could just put this data into BigQuery, and you can query them later to get some insights out of those. Let's move towards our hands-on. Before I move towards the GCP itself, right? Working on things there. Any doubts on the things that we discussed here? If it seems a bit too much, I think you will be able to understand more of these things when we actually work with them the next few hours. So I assume that all of you have GCP accounts to start with. From that point on, I can start showing you how to do things. Let me just move towards my other tab. So can you confirm that you can see the console on my screen, on my browser?
We can, Milan, but it's a bit too small.
Yeah, I will expand that. Yeah, I will expand when I do something. So if you open the Cloud Console, right? Yeah, this is a screen that you would get. So the link would be console.cloud.google.com. Let's paste this here as well. Yeah. So let's start with a new project. And yeah, before I begin with this, so if you sign up for a new account, GCP account, you would also be eligible for the free trial and the free tier. So these are two different things. Free tier is limitless, so it does not expire anytime, and it's just at free. It's a free access to a couple of GCP resources per month. So it spans across most of the services. But there are limitations. Let's say it might be towards the region or towards your monthly usage, but that does not expire. And what your free trial is that you get $300 that you could use towards resources here, and that expires in 3 months. So whatever we would be doing would be charged towards those $300, but it won't be much since we'd be using it for the next 3 hours, right? So it'll probably be less than $10, and it'll be charged towards the $300 credit that you would receive. So let me put in a project name, and this project name is permanent, so you won't be able to change this after you've created a project. And speaking of hierarchy here, everything starts with your project. So if you have an organization, then things start with an organization. When I say organization, I would mean something like google.com or let's say YouTube or things like that. So if you have a domain name, right? Something.com, and you have an email from that, and in that case you can start with an organization. Within an organization you can have folders, and you can have projects within those folders. So since I'm using a Gmail ID, I just created this ID yesterday for the purpose of this workshop. So I would be starting with the project itself, and let me put in the name as yeah, this is available. So if this name is not available, your project ID would be a bit different from your project name. So there would be some random number after the name. So this is permanent, and you won't be able to change it. So I click on create. Are you with me till now, or is anyone facing any issues at this point? All right. So the project is created. So let me just select the project. And yeah, just to confirm that you have the free trial, it'll show up here at the top side. It'll tell you the credits that you have and when it'll expire. If it doesn't show for you, it normally does. If it doesn't, you could click on your billing, and it'll show it to you in the billing part of things. So I think I have to associate this project with billings. So there are two ways to navigate between different things on GCP. You could just type the name here to get things, or you could click on this icon, and you will get this bar where you can check things out. So I will show this to you with billing. So yeah, when you click on billing, you will have to see this. So if you see this, you have the free trial. If you don't see this, you will not have that. In that case, if you've added a card and if you've upgraded, the only possible way of you getting charged is that you're done with the free trial and you've opted to go for the full access type. So this account that I have here, right? So it'll expire in two ways. One is if I complete the 3 months that I have, the 90 days, it'll go into suspended mode. Or if I spend this $300 beforehand, the moment I spend the $300, it'll go into suspended mode. And even though you have resources, your payment method will not be charged at that point. It will just be in suspended mode. The only way that it would be charged is that you go and click on this activate, and you go into the full account mode. In that case, your payment method might be charged if you go beyond this $300 limit that we have. So that is one other advantage that you have when you use Google Cloud. So you don't have to worry about being charged. So unless and until you go towards a full account, you will never be charged. Your account might go into suspended state, but you won't be charged. That's one assurance in Google. So yeah. So let's start with storage, if that's fine, because it's quite simple. Let's start from the simpler things, and then we move. Let's move towards the complex aspect of things. So at the end, we will do probably virtual machines and stuff. Right now, let's start with the cloud storage itself. So on the left-hand side, when you click on this icon, if you come a bit, if you scroll down a little, you would get something called as storage. Within storage, you have files store, you have data transfer, and you have storage. So this is the GCS. This is Google Cloud Storage. You can click on storage, and it will take you to the storage browser. So in GCS, we maintain files in terms of buckets. So we create buckets and we put data within these buckets. So a bucket would have like a unique endpoint, and you could access your data through that endpoint. So this endpoint might be different for let's say different use cases. So if you want to view this file through your browser, we could get an HTTP endpoint. If it's something to do with your console itself, you could use a different kind of endpoint to interact with different buckets or to move data between your machine and the bucket. The reason why we would use this is that this is not just to, let's say, host files on the internet. So that's one use case. You could store your static files here. You could put your, let's say, CSS or JavaScript files or images or videos, any of the static objects into the cloud storage, but also to interact with other services of Google Cloud, right? So if you're, let's say, running some image recognition service, if you use the vision service to run vision service on a couple of images and to get insights or to match, let's say, faces, or to let's say get labels or any insights that you get out of an image, all of those files you could store here and use those files in those other services. So let's go ahead and create a bucket. The name of the bucket is not let's say unique just to your project. It's unique to Google itself. So you'll have to put in a unique name that is unique throughout Google Cloud. So let me put my name itself. See if this is available. Also, different types of storage, right? So if you have regional, dual regional, multi-regional, what this means is that it will replicate your data. So if you put region, it'll ask you which region. So I actually did not talk to you about regions. So just to give a summary about regions, we have a couple of regions. So I think it would be somewhere around 50s, I think. So these are different regions. They're named as, let's say, US-East 1, or let's say for Mumbai, it would be Asia-South 1. This is the data center of Google. This is the region. So between these regions, you would have Google's fiber connection. So the preferred option is to select the one closest to you. So within a region, you would have availability zones. So that might be something like for Mumbai, it would be Asia-South 1 -A, B, or C. So these are availability zones. These might be different buildings within the data center itself, or let's say different segregations there. So if you want like a regional replication, you could have your application in different availability zones within a region. So if something goes down on one side, you're assured that your application would serve from the other side, right? And if you have it across regions, it might be, let's say, a multi-region. So your data would be replicated between different regions itself. So if you put like Asia or United States or Europe, between it would be replicated and it will be stored in different regions across that area. So that's what this is. But there are different pricing for each of these things. And for demonstration here, let's just go with regional. And I would choose. I could go with, let's say, the closest one is Mumbai. But there is one problem here, is that Mumbai, for a couple of resources, it's close to capacity with GCP. So for few of these things, we will not have enough quota to create resources. So the next best thing after Mumbai that I have is Singapore. So I'll just go with Singapore. And the type of the storage class, right? So there are different pricing for each of these things. Standard is the normal one that we would use. So charges would be in terms of two things. One is your storage size itself. So it might be, let's say, 5 GB of data or 10 GB of data. So you'll be charged for that. And the other type of pricing is your operational pricing. So there are two types of requests. One, it's Class A or Class B request. Class A would mostly be, one of these types would be, writing things to your bucket. So if you want to upload files or delete something out of it, I think delete would fall into another class. I'll have to look that up. But basically, it would be writing or updating things or changing metadata of things. These things fall into one type, and you'd be charged something for that. And the other would be reading from this. So you normally do not write much to things, right? So if you're hosting some application as a static file, you just upload that once. But in terms of reads, whenever somebody visits your website, it will be read, right? So there's a different kind of pricing for that, and it's lower than the right one. So there are different pricing for each of these things. Standard is for your like normal files. Nearline, code line, and archive, right? These are for backups and other things. So nearline is for your backups, and this is meant for cases where your access is less than one time a month. Then you have code line, and this is for disaster recovery. So you back up everything here, and you don't access that at all. Only when something goes wrong and you lose your data, that's when you go back and access data from here. And your archive is a very long time storage. So you just put data there, and after a couple of years, if you need it, you just look them up. So there are different pricing, as I mentioned, for these things. So your storage pricing might be higher for standard, and it will be lower for archive because you're storing it for a very long time. And your operational pricing, right, to read it or to write from it, it'll be lower for standard, it'll be higher for archive, because you don't like go and access your archive every few hours, right? It's only when things go wrong, and that's when you actually go back and check some files from your buckets. So let's go with standard. And access control, you have uniform and fine grain. We could go with either of these things. I would go with uniform. What uniform is that for your entire bucket, you have one type of access here. So you could define who would have access to this bucket. You could define like whatever role you want. You could give them view access, or you could give them list access. You could give them write access to it. So that would be your uniform. What fine grain does is that for a particular object, to the object level, you can define permissions. So within a bucket, if you have a couple of folders, and within that folder you have a file, you can define different permissions for that particular file itself. So that is your fine grained access control. All right. In terms of keys, so all your data, right, is encrypted when in storage, also when in transit. So when it's stored in Google data centers, right? Let's say by chance somebody goes inside and pulls out the hard disk. If they connect it to their computers, they won't be able to understand anything because the data is encrypted. And you have a couple of options to encrypt that data. So Google can create a key for you and encrypt that data from Google managed keys, or you could upload your own customer key, your own key, and that data would be encrypted in the data centers. So that's how you maintain the confidentiality of this data. So retention policy is something to do with when you delete this data. You could put in something like all the data that I have after, let's say, 1 year should be deleted. So you can set those things up here. So you click on create, you'll have a bucket created for you. So this is a bucket. There are multiple ways in which you can interact with the bucket, not just the bucket, with everything on GCP, right? So any service that you look at, you could, let's say, provision or make any changes to that on your browser. You can do that from your console using the gcloud tool, or you could do them through the API itself. Ultimately, all of these things translate back to an API itself. So you would have a REST API endpoint. You can authenticate and use that API to get resources there. So even when you do something on the browser, or if you use the command line tool, ultimately it will translate back to an API call itself to Google. So for the sake of demonstration, I have created an HTML file. I'll just show that to you as well. And yeah, we will host that. Let's host that static file from here. So I just created a folder called workshop, and I have these files. I'll show these files to you. Yeah, use Sublime as a text editor. So this is a simple HTML file, just for the sake of demonstration. If your intent is to only deploy and host a static website, right? If it's just like HTML, CSS, and JavaScript files, so it might be a React application or any such front end framework application as well. Ultimately, it would be static files, right? You could do it from the cloud storage itself. You don't have to go towards any of the compute resources, because it would just be these files being served from a location to your the front end, to your browsers. So this is a simple HTML file, and let me upload this and show you how to make this public and get an endpoint out of it. So this is the file. I'm just uploading it here. I just use the browser itself to keep things simple. I'll try to do most of the things that what I can do in the browser itself. And if I cannot do something in the browser, I will use a Cloud Shell here itself. So there is no requirement for you to install anything on your local machines. So even the shell you could use from uh, the Google platform itself. So this file is uploaded. Since I have uniform permission, right? I can just click on permissions, and it shows you this is it's not public. To make it public, you will have to add a role, and this would be all users. So if you click on all users and give storage object viewer role. So if you select, if you give permissions to all users and give the role of storage object viewer, your the bucket becomes public. So it'll ask you one more time to confirm to allow public access. And I updated it. Now, yeah, it shows you a warning as well, stating that this is public. It's accessible on the internet. So going back to my objects, it shows you that there's public access, and you get this URL. You can click on copy URL, and you can just paste that here, and yeah, your file is posted. This is the HTML file that I just created, and this is being posted. So any doubts still here? So till now, we just looked at cloud storage, our GCS bucket. We made the bucket as public, and we put a simple HTML file inside that, and it's public right now. Any doubts still here?
I had a question.
Yeah.
What is the advantage of having like GCP cloud buckets over other buckets like AWS or Azure or so?
So yeah, I can't really comment on the comparison between different providers here. So yeah, I think that would be my stance here, since I work in Google itself, and I can't really comment on other competition here. It would breed some policy here. But it'll pretty much be the same. They'll have different ways of setting permissions. They would probably have different limitations or different pricing here, and a couple of different features which might be different from different providers in terms of the storage buckets. For a couple of other things, I mean, there are obvious differences, but for cloud storage, that would pretty much be the difference.
And another question I had was, how would the data be partitioned? Would they have like just one huge bundle of data, like hard drives, and then just as required partition them off and give it, or would it be like separate server racks?
Yeah. So in terms of cloud storage, right? This bucket, so Google Cloud Storage, you don't manage the backend infrastructure. So your data is not stored in, let's say, one server. So there would be one infrastructure in such, I mean, designed in such a way that it's a distributed system. It's a distributed file system itself on the backend side of things. So for you, it would just be an object stored in a particular region. So I think you could not even see where, in which zone this was stored, right? It was just a region. You could just select, let's say, if it's a regional bucket, you could select to be, let's say, Mumbai or Singapore, and you will not know where it is stored, because it's a cluster of servers serving these files. It's not just one server, and it's not like something similar to the file systems that you've known. So it's not something like NTFS or FAT32 or anything like that. There'll be a proprietary file system that the company owns, and they would have a serving infrastructure designed in such a way that the data would be stored somewhere, and the metadata of that would be stored somewhere else. And when you request for things, let's say listing things, or request for the object itself, will be routed, and the object would be returned back to you. So that is how things would be stored. How exactly, there's a question, how exactly would you define storage buckets, since you can't exactly define them as files? Yeah, Tejashree, please don't call me sir. First, so you kept in public. So is it that only visible to the selected region? It is not only visible to the selected region. So the assurance that you get out of putting the region, right? So if I put let's say Mumbai, you will know that it is stored in Mumbai. So your latency, right? Your latency would be low. So the reason why we select the closest region is that the distance between me and that region would be lower, and the latency, which is your ping, will be lower in this case. So I can store something in let's say US and then access it from here. So the latency, which is the let's say, if I have a page, or if I'm storing a video right somewhere, a big file, uh, and hypothetically it's in US, and let's assume the distance between US and us is too huge, okay? And let's what would happen is that the first time that you click on the link or click on download, or if you're displaying that on a web page, it would probably take you a second or two to load. Once that starts, right, then you won't have any disturbances, because your internet speed would be the same. Only the latency would be higher. So data is stored farther away, and it will take some time for that data to reach you. And it is not 2 seconds; it will be less than that. Yes, not through Cloud DNS. You could use CDNs. So when you run CDNs on top of these things, just for people who do not know what a CDN is, it's a content delivery network. So what that does is that those are bunch of edge servers. They're designed only for the purpose of caching. So there might be one region in India, but there might be multiple edge servers within India itself. And if you set up a CDN, what it would do is that these edge servers would cache your data. So it will request your GCS bucket one time, probably the frequency that you put in. I can put it in such a way that it will query that once a day, and it will cache that file. So every time you request for something, when it reaches Google's infrastructure, your CDN would respond first. So whatever is cached within the CDN itself will respond back. Whatever is not cached will be returned from your bucket, and it will be cached in your CDNs. So that reduces your latency. The first question, I think I missed the first question. Hardik, these are actually files itself. These are stored as buckets. These are files, but it's not the normal file system that you would have. So these are stored as blobs. If you know what a blob is, it's like a binary file. It's just huge chunk of objects being stored somewhere, and within a different file system. And metadata of these things might be stored somewhere else, probably in a different kind of database. And when you try to access it, and the infrastructure would be built in such a way that these things would be returned. So these things would probably be proprietary to the company, and they would keep these things confidential. But to an end user, right, it's just an object. To you, when you look at things, you could see this in your cloud console itself. You could look at buckets here. You could get access to you could get an endpoint of a bucket and have relative path to your files. So if you have let's say, if you're hosting an entire website out of a bucket itself, you could just store your files here, get an endpoint to this, and run them. So to you, it will just be a path. What you will not have here is that the difference of these objects from the files, right? As you've asked, you will not have your POSIX permissions. You will not have let's say, you can't do chown, you can't do you can't change permissions in the way that you do in Linux. So yeah, you cannot have symbolic links. You can't have hard links. So these are the things that you get in your file system in let's say Linux or Windows environments, but you will not get this in objects. I think that clarifies your question, Avanish. Sorry. So yeah, any other question on GCS, or can we move ahead to other parts of things? So yeah, since we are in the storage itself, right? Let me also show you our SQL part itself. So this takes a bit of time to start up. So we could do something else by the time this gets ready. So yeah, I can click on SQL within our databases part here. So create an instance. Let me go with MySQL. I'll just put this as SQL1. So this should be unique to your project. So it's not unique to Google itself. So it's just unique to your project. You can have whatever name you want, but you can't repeat them within the same project. And you can create as many projects as you want as well. So you're not restricted to one project. So just for simplicity, I'll just go with no password, never do this. the region. As I said, I'll not go with Mumbai. I'll go with Singapore, and I'll just keep the rest of the options as is. Uh, Configuration. So you get a couple of other options if you want to look at them. I can just explain what these are. I've put this as public IP, so you can have like private networking itself and not enable public networking. Machine type, you can select a different type of instance. This is similar to your virtual machine. Whatever type you put in, you can change this. So right now it's giving me 4 cores and 26 GB of RAM. And in terms of storage, I can select SSDs or hard disk, and it's SSD selected, and I've been given 100 GB. I can change these things. So one thing to note here is that a lot of things depend on your storage size, not just type. So if I'm going with SSDs, the larger size that I take, right? If I put in more than 100, if I put like 200 to 300, your throughput also changes. That's because your storage is organized in such a way that the more storage that you get, you could like in public terms, you could look at it as RAID configurations. So the more storage that you put in, you could read simultaneously from different drives, right? So your throughput will also increase. Yeah. So yeah, so we can leave all of these things to be default. In backup and recovery, high availability. If you choose high availability, you'll be charged double the rate that you normally have for an instance, but you will have another failover instance running at the same time as your normal instance. So let's say something happens to your master server, it goes down, your application will not stop receiving requests from your endpoint. So all of the connections would be rerouted to your failover instance until your main instance comes back online. So that is a high availability. And maintenance, you can select your maintenance window. So if there are let's say some updates that have to be rolled out to your instance, right, your SQL instance, you can select the window in which this can happen. So there will be a downtime when you have an update, and it will be a couple of minutes or even less than a minute sometimes, but you can select which window you want. You can select what day and what time, and this would happen at that time. And order is basically, you have a couple of channels here. You have later and early channels. So if you have like two databases, you could put earlier happens 1 week before your later one. So you could, to test things out, you could put earlier for one of the database and one of your instances, and put later for another instance. After the update happens on one, you can check if things work out for you, and then move to the other one as well. That's maintenance. Labels. It's basically a label that you can refer to at a later point. I click on create, and this will be created for me. It'll take some bit of time, and in that time, I think we could talk about the storage itself. Any doubts till here? And are you following this with me, or is this more of a demo? One thing about remote workshops is that I cannot, come to you and see if you're getting it, if you're doing it on your machine. By the time this thing sets up, let's go back to our cloud storage. All right. So one of the things when I asked the questions, right, one of the things that you could have asked me was that this endpoint, right, whatever endpoint you're seeing here, it says index.html. It's not slash. So if you were to point your domain to this custom domain, you cannot point it to index.html. You will have to point it to a domain name. You can't point it to something something.com/ some endpoint. So how will you do that? That would have been a good question here. So you cannot directly point your domains to let's say your bucket. You can, but you cannot set up SSL to this. So there is a configuration for your buckets itself. If you name your buckets as your domain names, something in the format of a domain name, let's say something.com, it might be nisb.in. So if you name that as your bucket name in your settings, you get another option to set what would be your index and what would be your 404 page, 404 error page. So those things you can set up there. But if you name it something else, you won't be able to do it from your console. You can still do it from your from your terminal, from by using gsutil tool. You'll be able to set that. But what if you want to, let's say, configure SSL and have, let's say, HTTPS connections through your custom domain to these buckets. That's where your balancer comes into picture. So we have like different kinds of load balancers. You can just use an HTTP load balancer and use this as a backend. Your bucket as a backend instead of a VM, and you will get a static IP address to your load balancer. You can point your domain to that, your custom domain to that in the DNS, and you can set up SSL there as well. So your load balancer would allow you to configure a couple of things. You can configure backend, you can configure your front end, and you can configure load balancer itself. If you have like multiple buckets or multiple backends that you would have, you can configure it in such a way that let's say in one of the virtual machines, if the CPU utilization goes above 80%, route the request to another backend. So you'll have all of those options with load balancers. So let's go to our SQL. By this time, I presume that it would be done. Yeah, it is still running. All right. Any questions till now? All right. By the time that this spins up, I'll also tell you something about read replicas. So we've talked about high availability, right? So we've spoken about your failover instance, which would be running in a different zone in case this instance goes down. And the purpose of that instance is only to respond back or to take in connections when this goes down. But what if your use case would be in such a way that you write to your instance, let's say, let me take an example of 10 requests per day. So you have like 10 insert operations per day or something like that. You're writing only 10 times a day, but you're reading 10,000 times a day. So if your use case is in such a way that you have a limited number of writes, but a huge amount of read operations from this, that is where your read replicas come into picture. So read replicas are just replicas of your instances, which only work as work for reading. So if you're getting a lot of requests, you can create more read replicas here, and your requests will be divided among those read replicas. So you can read from these replicas, and whenever you write, right, you have to it will be written to your master instance, or this instance, and it'll be updated among all of your read replicas. So that is one other advantage you get out of your managed SQL instance. So since this is created, let's connect to it. So so this is something called as the Cloud Shell. This is a shell that you get in your browser itself from Google Cloud platform. And internally, this is just another virtual machine itself, a temporary virtual machine of a very small size that you get here. And it's within your network itself, within this project, and it's authenticated to your project. So you don't have to authenticate again and set your project, set your account, and things like those. So to interact with Google Cloud, right, from your command line, you need a tool. You need the gcloud SDK. So this is the SDK that you would require if you want to do it on your local machines. From let's say if it's Windows, you could have like your command prompt, or with Linux you can have your terminal, and you can interact with GCP from those terminals itself. You would need to install your gcloud SDK. On shell, it is installed by default, so you could just use it directly. So to interact with your SQL without having to do it in the normal way, which is installing MySQL and then using your public IP address as your host and authenticating and going in. gcloud gives me an easier way of doing things. I can just use gcloud SQL and the instance name. Connect the instance name SQL-1. I'll have to authorize this Cloud Shell to interact with my GCP services, and the SQL admin API was not enabled. When you create an object, when you create a project, it will not be enabled by default. You will have to enable it. And since I need it to run this, it asked me if I want to enable it and try it again, and I went ahead with it. So it is doing this for me, and it's allowing my IP address, whatever the address that I have right now. have connections to the SQL. So nothing is allowed in your connect to your SQL instance. You'll have to manually go and whitelist things. Let's say IP address ranges, or if you're using a proxy, the SQL proxy here, you would have to add like different connections to it. So you'll have to define what type of connections are coming in and whitelist those things. So this is different from the firewall that we have for your SQL itself. You have different connection types. So I did not put a password, so I meant. So if I can, show databases. I can just create a database. So yeah, the same thing that you do with the normal SQL installed on your machines itself, right? So it's the same way to do these things. In your applications, you could use different drivers. There would be different drivers for different platforms, right? So Python would have different modules that you could use to interact with MySQL. It's the same thing with Node.js, and same thing with PHP and Go and stuff. So for different platforms, you'll have different drivers, different modules. You could use those modules, and you can put the IP address, the public IP address, as the host, and let's say your databases and your user names and stuff to interact with the database. So that's how you do things with the SQL parts of things. So let me show you how to create a replica. So yeah, you can create like users and stuff here. So instead of doing it directly within the prompt, you can just manage them here itself. You could also manage it in such a way that the users for your project, right? People who have access to your project could have access to your instances. So these are things that you could do with things. So if you can't failover, failover is when like you manually trigger a failover. So in such a case, this would go down, and your failover instance will take over. Wait.
What kind of delay would be there when something fails over?
I would presume that there will be a slight delay, but it won't be a lot. So what happens is that you have this heartbeat, right? So your instance's health is checked. So periodically a request will be sent to your instance to check for heartbeat. So if it's not responding back, and this is checked for a couple of times. So if it's not responding for a couple of requests, it will fail over automatically. And if not, if you put it to fail over, it will move towards your backup instance. But it'll be I don't know this to be exact, but I presume it to be a short delay because your failover instance is also running at the same time. So only your connections have to be routed to that.
So a failover runs all the time, even when it's not needed.
Yes.
So it's not like
it
it's on
runs
standby and only when it's needed it comes back. It spins up and then goes.
It is in standby, but it won't be responding to your request. So we call it standby because it's not doing anything. It's just being updated, and only when your master instance goes down, that's when that becomes active. So you will be charged for both the instances. So yeah, in terms of charging, it would be double. So if you click on create read replica here, yeah, just go with the create replica. So this would be another instance, and this would only be used for reading. So if your requirement in such a way that you're reading a lot from this. So in such a case, you can create more read replicas. So you can have, I think, I'm not sure, but I think you can create 10 read replicas for a database. So I'm not sure on that, but there's a limit on the number of read replicas that you can create. And yeah, those would be your replicas. And in terms of performance itself, right? So you could have like a higher capacity read replica than your master instance itself. You could have, let's say, 8 cores instead of 4 cores to read things. So yeah, those are the flexibility things that you would get when you have read replicas. Yeah. Okay, it's 3:15. Let's move towards computing, right? So we've looked at storage, we've looked at object storage. We looked at SQL storage, and now let's move towards computation itself. This will probably take some time. So usually setting up SQL usually takes more time than setting up your virtual machines itself, because internally it runs in the virtual machine itself, right? So it'll have to take up an image, configure that, and it doesn't give you access and stuff. So it takes a bit more time than your virtual machines itself. Let's go towards the compute engine. So on the left hand side, right, when you click on this icon, you have compute, storage, databases, networking, and stuff. So within compute, you have your app engine, your compute engine, Kubernetes, cloud functions, cloud run, and VMware engine. So let's look at cloud functions. We'll finish this very fast. So as I said, in cloud functions, you don't do anything. You don't manage anything. You just write a function, right? So I think the API is turning on now. So let's give this a minute. So you just write a function to respond to a request. So you will get your request object. You can check what data is there in the request, and then you can respond based on that resource. So whatever is being requested based on the endpoint and based on whatever you send as data, you can respond back. So let me go create a function. You can do this with me. So this is quite simple. You can test it out here as well. So let the same thing be here, and let me take Mumbai. You can put in US as well. It'll make no difference to you. It's just that your latency might be higher. So if it was a virtual machine, and if you're SSHing into some an instance which is in US, you will see a lag between you typing in something in the console and that showing up on your browser. So that's the latency. So this is where you authenticate, or you allow access to unauthenticated invocations. So if I put requires authentication, you'll have to authenticate in one of the ways. There are like different ways of authenticating. Simplest way, you could just create an access, an API key for your project, and you could just append your URL with that API key, and you'll be authenticated. So I'll just go with unauthenticated. Sorry, and in terms of trigger, right? You could go with HTTP trigger, or if it's cloud storage, you can set it up as a notification. So you could do it in such a way that if you upload some object to a particular bucket, you can trigger this function. Or there are a couple of other options here. This PubSub. PubSub is like for your IoT applications, right? If it's like MQTT or something. So if you know something about PubSub, if you don't know anything about PubSub, it's a different kind of communication protocol. So you would have a topic, people would subscribe to that topic, and there would be devices which would publish to that topic. So whenever let's say somebody is subscribed to a topic and someone else publishes to that topic, the people who have subscribed would receive that message. That's a PubSub model, and we have a PubSub service as well in GCP, and you can use that to trigger. For simplicity, I'll just go with HTTP. Unauthenticated. You can set up different variables and stuff here. So what memory allocation, timeout, and other environment variables and stuff. So we will need to enable the cloud build API for this to work, and I'll just enable it right now. And since we're just doing the basics of things, I'm just keeping, I'm just scratching the surface here. I'm not going in depth for any particular product. So by the time cloud build is enabled, I'll just tell you what cloud build does. Cloud build is, it's used to build your application. When I say build, you can do it in two ways. You can do it through Dockers, or you can do it like by giving custom, commands, custom instructions to cloud build. So whenever a build happens, a machine is spun up. It might be a virtual machine. I'm just keeping it simple. In exact terms, it would actually be a container which is spun up. So a machine would be spun up, and whatever you've told it to do, it'll do that, and it'll terminate. So that is what build does. So to give an example, let's say if I set it up in such a way that whenever I push my changes, whenever I commit and push my changes to GitHub, right? I want a build step to execute. So I can do it in such a way that whenever I push something to my GitHub repository, cloud build will fetch files from there. It'll build a Docker image out of that. it will deploy that image to the container repository in Google Cloud, and it will run that either on, let's say, App Engine or Cloud Run. So all of these things could be configured, and Cloud Build will do that to you, do that for you. So if you don't want to use Docker, you can define different steps. So each step would spin up a new container and do whatever you've asked it to do in that container. And whenever that step is done, that container is killed, and each other step will create a new container. But your data, right, your working directory would be synchronized among all of these things. So you will have a static directory under which you could keep your files for the duration of the build, but the containers would be killed after each step. So that's to do with cloud build. So it's enabled. Let's go back to our cloud functions. I'm a Python guy, so I'll just choose Python 3. So this is basically a Flask implementation of things itself. So it will just return hello world if I don't send any data to the request, and if there's any message within the body, it'll return whatever message I've sent. So this is the sample function that they've shown. What I can do extra here is that if I want to use some module of Python, right? So if I, let's say, what examples? If you're using NumPy or SkyPy or any of those modules, you can put those under requirements.txt here, this file. And whenever this is run, those things are also installed for you. So I just go with deploy with whatever function which is already given to me. So we can test this out. So this will take, I think, a minute to start. Once it's done, let's test it out. You can do this with me as well. It's quite simple. It's a couple of clicks, and we didn't type in anything.
Milan,
Yeah.
I had a question. Okay, this is kind of a question that me and a few other friends usually have. Would it be better to have like a entirely serverless based backend, like all cloud functions, or would you prefer like a traditional server based?
Yeah, the thing is that for most of the applications, right, the highest level of abstraction that you can get to is the container level. You cannot go to the function level. So you would have dependencies. You would have requirements in applications which would limit what you can do. So you can bring it down to your container level, but you will probably not be able to bring it to your function level, because you can't do much with functions here. So even with this thing, right? Even in Python with your requirements.txt file, you could only do limited things. You can't do everything that you can do with containers or your VMs in the function itself. But where would this help is that if, let's say, if you're building an Android application or some other front end where you're doing most of the things on the front end itself, and you don't want to directly communicate with your, let's say, databases or any of your data storage on the back end, and you want to do some confidential things that you don't want to roll out to your front end of your application, you want to do something on the back end. In such cases, you can just have these functions to do small things. So let's say authenticating or requesting some resources from somewhere. Let's say if I want to run some SQL query and get responses to that, you will not be doing that directly from your Android application. It's not ideal, or in terms of security, it's not at all good to do that on your Android application. So you will have to interact with your backend to get this data. And in your backend, instead of having an entire virtual machine to do all of these things, you could just have a function to do that. So this is spun up. Let's just test it. You can just click on this actions and click test function, and you'll get this. So I'm not sending in any data. I'm just going to go ahead and click on test this function. So it says hello world. That's what it was supposed to send. So let me send a message. What message do I put? I'll just put hi, Pranav. So technically, according to our function, it's supposed to return hi, Pranav. Yeah, it did that. Yeah. So yeah, it's quite simple. Functions, you don't have to worry too much. You can pick up the language that you like. You can pick up JavaScript. You can pick up Python, and you can just write your normal Python function itself there and return what is supposed to return for this endpoint. So yeah, this is how, and if you want to do it through your browser, this is the endpoint. You click on trigger and you click on this, and it will give it to you. So to test it out without this, you could use probably use Postman, or you could use curl on your command line to do it. So let's go back. Before we go towards our compute engine, right? Let me take a couple of minutes to talk about VPCs as well. So yeah, the one advantage that you have in Google Cloud, right? Specifically in Google Cloud, your VPCs, go across the world itself. You're not limited by a VPC in a particular region. So you can have resources in different regions, and you can have a single VPC for all of those regions. So what VPC is, it's basically a virtual private network. So you will have one network in a VPC, and you can have multiple subnets within the VPC, and each device within a VPC can communicate among each other. So let me enable this API. And you can set different firewall rules for a particular VPC. And even between VPCs, you can you can create a pairing connection between VPCs. So um, one advantage that you'll most likely see if you're not much into this is that once you create virtual machine instances and stuff, right? You can refer to them by their host names directly if they're within the same VPC. And in terms of communication also, right? So all the resources that you have within the VPC, you can define permissions in such a way that only the devices within the VPC can communicate to it, or let's say you can make it public to the world. So all of these things you can do with a VPC. So there's not much with this. I just want to show you and start our own VPC here. So when you create a project, you're already given a default VPC. So you'll have a VPC with the name of default with subnets in each region. And again, whatever I'm doing here, right, with the browser, you can also do it with your command line. You can use your gcloud SDK itself to do it, or if you want to programmatically do it, you could use our REST API as well. So you can have a program send a get or a post request. So there are different types of requests for different operations. To create something, you could do you could use a particular request. To get a list or to get details about something, you could use get request. So things like that, you could programmatically call that call the REST API to get or do things. So yeah, this is our VPC. As I mentioned, you're given a default VPC when you create a project. Let's create a new VPC. I'll just name it workshop. And yeah, your subnet creation, right? You can do it on your own. You can define whatever what subnets you want for a particular region, and the IP address ranges for that. But you could also use automatic. Automatic would give it to you on its own. So Google itself will give you different subnets for your VPC for different regions. I'll just go with automatic. So I don't want to put in IP addresses for each of these things. Then your firewall rules, you can select whatever you want. So I'm just going to allow ingress ICMP. ICMP is for your ping request. Then this is for communication internally within the VPC. RDP is for your to connect if you're using like a remote desktop connection to visually see your virtual machine. If you're running a desktop in a virtual machine and you want to visually see that, you could use RDP. SSH is your secure shell, the one that I showed you with the Cloud Shell here. You could connect your instance through SSH. So in your terminal, you'll be logged into your virtual machine, and that's SSH. So in terms of routing, regional is fine. So you have a couple of network protocols, right, which periodically share routing information among themselves. It's just that you can do that regionally or globally. Let this happen. Let me use the default one itself. This is taking a bit time to set up. Let's go ahead with the default VPC itself. It's fun. Firewall. All right, let's go to our compute engine. I just want to point out here is that like there are lots of things in virtual machines within GCP itself. So if you feel that this is too much and if it's going over your head, you could, like please let me know so that I can change my content based on the requirement itself. So let's start with the virtual machine. So yeah, you can give any name that you want to your virtual machine, and that becomes permanent. You can select a region, and we will not have quota to create a virtual machine in Mumbai. So let's go with Singapore, and then the type of your machine. So E2 is basically whatever is available. You can get that, or if you want to specifically get a type of CPU, you can select N2 or ND2. N2s are like Intel Cascade Lake CPUs, and ND2s are AMD's processors, and N1 is like legacy. It's old generation Skylake CPU platform. I'll just go with E2, and you can select the machine type. So you have shared cores, and then you have these other configurations. If you're not comfortable with these configurations, you can just select custom and put in whatever number of cores you want and the number of RAM you want, the size of the RAM you want. I will just go with standard for virtual CPUs and 16 GB RAM. And your boot disk. So yeah, in the free tier, you will not have access to attach a GPU, a graphic card to your virtual machine. But when you're out of the free tier, when you're in a full tier account, you can also attach a GPU to your machine. So you have two options here. You can select an image, or you can deploy a Docker container on the virtual machine. You don't have to go in and install anything. You just go with a container itself and put the path of the container. So I will just go with an image itself. Let me select Ubuntu, and let's go with Ubuntu 20.4. The disk type, you have standard, balanced, and SSD. I'll go with SSDs and 20 GB of storage. So I've set these things up. And then you have access, right? So from this virtual machine, do we want like default access, or do you want full access to all of the cloud APIs? You can select those. And in the firewall, you can select HTTP and HTTPS if you want to serve web traffic from your virtual machine. So I'll click on create. So I think this would take about 10 to 20 seconds to give you a machine. So one advantage that you have on GCP, right, for virtual machines and stuff, you can SSH to it directly from here. So you don't have to download let's say your private your private keys, your key pairs, and then log in from your local terminal to the instance. You can directly do it from here. So the instance is created. What this means is that Google Cloud has provisioned the 4 cores and 16 GB and 20 GB of storage for you, and it's installed Ubuntu 20.04 for you. So the reason this happened fast is because each of these images, each of these operating systems, they've been installed, and an image of that has been created, and that image has been copied to this 20 GB that you have. So that's the reason this happened fast. And as I mentioned, you have this private IP, internal IP within your VPC, and you can use this for communications within the VPC. And this is your external IP address. So from the internet, right, you can reach this instance through this IP address. So one thing to note here, right, is that if I go to this particular IP address itself, external IP addresses. So you can see that it's ephemeral. So this is a dynamic IP address. So every time you stop and start this instance, you'll get a different IP address. And you can't work with those IP addresses if you're hosting, let's say, a website from your virtual machine. So you will need a static IP address, right? So if you're, let's say, pointing your domain, right, custom domain to this, if you're creating an alias record, you will have to put an IP address there, and that has to be constant. So I'll just go ahead and change this to static. I'll have to put in the name, which is put instance 1. in terms of pricing, right? I think the first few addresses, you can look up pricing. I'm not sure of the exact pricing. As far as I know, the first few IP addresses, static IP addresses, are given to you for free. You don't have to pay for them as long as you're using them. So it shouldn't be that you allocate this and you don't assign it to something, or you stop your instance and you've assigned a static IP addresses. In such cases, you'll still be charged. So I have made this a static IP address. Let's go back to virtual machines. So yeah, if I just click on this SSH, right, it'll open a terminal. It'll open a window for me, and I can. This is an SSH terminal to my virtual machine itself. I don't have to manually do it on my computer. I can just use this to interact with my virtual machine. Yeah, so this is the terminal. So this is actually the machine that I just created. A couple of other points to note here, right? So if you have your own machine, right, and if you know how to authenticate with SSH, you can create a key pair. You can have a private and a public key, and you can copy your public key to the metadata here. You can do it per instance, or you can do it for your entire compute engine itself. So if you go here in the metadata, and if you click on SSH keys and add your machine's public key here, you can directly SSH to this to any of the virtual machines under compute engine from your local computers without having to put a username and a password. So I'll go back to the instance. As I mentioned, this is your virtual machines. You can do anything here. This is your Ubuntu machine. You could install anything. You could run any application. You can host a website out of this. Let me just run an update. This is something that I normally do. I do apt-get update after I get an instance, because the images are the latest to the operating system level, and let's say even recent after in terms of modules also, but it's not recent to date. So you can just run apt-get update for Ubuntu or Debian, and yeah, after that you can just go ahead with installing whatever you want. Let me demonstrate something. Let me show you how much speed we're getting. So this is a tool that I use to check the speed in the command line itself. It's speed test SCLI. So this will show you the network speed that we have to the internet. So as of this moment, we're getting 1.1 Gbps download and 1.02 Gbps upload. And this changes with the instance type. So if you select a higher instance type, right? If you're selecting, let's say, 8 cores or 16 cores or something like that, the network that you get will also be faster than this. But yeah, in normal requirements to install things, this would be more than sufficient, a gigabit speed for instance. But yeah, there might be requirements in cases where they would need a 10 gigabit network, and you can provision them as well. So yeah, what else do you want to do? So let me just host an index.html file itself from here. I'll not do it in the way that you're actually supposed to do in production. So I'll just install Node and npm. Any doubts till here? Are you able to create a virtual machine and SSH into it, or are there any issues? Okay.
No issues so far.
Right. So normally what happens, right, in a virtual machine, so when you have to run an application, you don't directly run it, you put it behind a reverse proxy. So a reverse proxy could be an Apache server, or it might be Nginx. So what that proxy does for you is that you can have multiple applications running behind that proxy, and it'll route that based on your origin domain. So you can have, let's say, abc.com and xyz.com pointing to the same virtual machine. And you can have two different applications running in the same virtual machine. And that reverse proxy will route that based on your domain name that's coming in. Also, it will queue your request. So if there are multiple requests, and let's say your application is not able to handle it, it'll spin up, let's say, more threads of it. So for example, if you're running, let's say, a Flask application, and you've put it behind Nginx or Apache, and every time a request comes in, a new thread is created, and your application is run there. So given that this is stateless, and if your application goes down, let's say for some issue, the application that you're running goes down, your reverse proxy will restart it. So your reverse proxy takes care of all these things, and even SSL, right? If you want to put HTTPS connections and put a certificate there, you could do that with your reverse proxy itself. That is how things run in production, but that takes a bit of time to configure all of those things. So let me just post a static file right here. So to upload a file, so normally if it wasn't for Google Cloud, you could use let's say SCP secure copy protocol to do it. You could use SCP command to move your files, or let's say you can use Git on GitHub. You could push your files to Git and you can clone them here. So in Google, you could just like click on this and click on upload file and select your file, and it will be uploaded. So it's quite simple to do all those things. So I'm just using an HTTP server from the NPM itself. So I just do it's called HTTP server itself. Just to demonstrate how things work, I'm just doing this. To run things on port 80, you will have to run it as sudo. So this is serving the file that we have, that I have here on this port. So can you open this IP address on your browser? I'll just paste this here in the command prompt. I'm not sure if I have access to it because I'm on my COP machine right now, and I'm on a different kind of network here. So are you able to see the page?
Yeah, I can see it. It says testing.
Yes, that was the page that we created back then. So for me, since I'm on a different kind of network, I won't be able to reach that IP address. Yeah. So there's a workaround, but it takes some time. But it's okay if you can confirm that it's working.
It's working.
But thanks. All right. So we created a virtual machine, right? So we've created a virtual machine here, and we're able to SSH into it. So what other things can we do with virtual machines itself? So let me just stop this part. Sorry. Yeah, it's just logging things. So let's say I configure a lot of things within a virtual machine, and I don't want to do it again if I want to spin up new virtual machines, or if I want to move this virtual machine to a different region. So that's where your virtual machine image comes into picture. So let me just exit out of this, and then I can open this instance, and then I can create a machine image. If I create a machine image, with that image, I can spin new containers. I'm sorry, new virtual machines itself. So I can just give a name, for instance, one, the region where I want this. So again, you can have this as multi-regional or regional. I just leave it at Asia. Also, the key for this image, you can have like Google managed key or customer managed key. Create. So this will create an exact image of my virtual machine to the current state. Whatever I've configured, whatever I have there, it will be this exact state. I can use that to create new virtual machines after this. By the time this happens, let me show you something else as well. So I've mentioned Nginx and other things, right? And in production, the things that you do, the way that you do things. You might have also heard of different stack like MERN stack or LAMP stack where you have things configured, or let's say having a particular architecture to run your applications. So Google has something called as this marketplace. Within this, you can search for pre-built images. So let's say if I want to have a LAMP stack, right? LAMP stack would be your Linux, Apache, MySQL, and PHP. So this is the stack that you have, and I can select one of these things and use them. So let me see. I want to use one which is made by Bitnami. Yeah, LAMP certified by Bitnami. You can check the pricing here as well. So it'll show you what would be the pricing. So Bitnami charges 0, but the virtual machine instance fee would be 474 rupees per month. Your persistent disk 10 GB would cost you so much per month, and with sustained use discount, which is this much, your per month cost would be so much. So you can go ahead and click on launch. So this will do most of the things for you. So having this virtual image created, and like setting up your network and things like those, your deployment manager itself will do that for you. So yeah, I'll just select the region, Asia Southeast one. Yeah, this is Singapore. I don't have a quota to create a virtual machine in Mumbai, so I'll just leave it at that. And my traffic, this is for the firewalls. I want to allow HTTPS and HTTP traffic. I'll just click on deploy. Okay, this is under the default VPC. It's not the one that I created, but let's just use default itself. This will take a minute or so to be created. In the meantime, are you interested to know how to set up DNS as well? I mean, buy a domain name and point it to a domain. If people are interested, I can show that to you as well. It is a bit out of scope of GCP. Yeah.
Anyone here interested? Won't that require us to buy a domain first?
Yeah, there is this provider called Freenom. So you can get free domain names. You can register free domain names here with this. Not sure if it's authenticated. So yeah, you can get like domains here. So you can get free domains here. So but once you set things up here, right, it will be the same thing when you buy a premium domain from either any of the domain name providers, certifying authorities. So this is a new domain. This code Milan-NISP. So let me register milan-nisb.tk. One month sufficient. This will probably take a minute or so. We can set up DNS after that with this provider. So I'll get back to the LAMP site. So this is deployed, and yeah, if I click on visit the site, yeah. So this is pre-configured for you. And since it's LAMP stack, we'll have to use a PHP application, a PHP file to host it. And since it's from Bitnami, they have like proper documentation to show you where to put your files and stuff. So you'll have to put, the home folder for you would be this. You can change that. You can change your Apache configuration to have host files from different places. I also just created a simple PHP file. Yeah, index.php. So this is the PHP part. I'm just echoing hello world here. Let's deploy this. So you can have like a full-fledged application here. Since it's Apache, you can probably SSH into this instance, install let's say Node or Python, and put Flask behind Apache or a Node application behind Apache to do things. I will SSH to this, and I'll just source this PHP file from there. Since you should be aware that like a PHP is not a static file, right? So it is a static file, but it has to be hosted somewhere. It has to be processed somewhere. There is some computation that is needed to run the PHP part on the backend side. So we can have our Apache do that for us. We just upload this file, and I'll just upload this PHP file. So yeah, the path mentioned here was this. I just move my file to that path. I would need sudo. I'll have to change the permissions of the file or use sudo to.
What kind of security rules will we need for a machine, for the virtual machine?
When you state security, I mean, what do you mean?
Let's say I'm running some kind of application on there. Apart from like software security, like my make sure my application is secure, how do I make sure that my virtual machine is secure so that no one else can access it?
Yeah, no one else can actually access your virtual machine. I mean,
Oh,
in terms of access, right? So from your console, only the people that you've added to the project, and also you've given the role of, let's say, compute viewer or compute, let's say, editor or compute owner, only they will have access to this virtual machine. Nobody else can get in. And whenever you click on this SSH button, right? So what Google will do is that it will create a temporary SSH key, and it will put that within your virtual machine. So a temporary key is added to that, and through that SSH key, you're able to SSH from this window. So and the people also the metadata that I showed you, right? SSH key is there. So if you had your local machine's SSH public key there, you'll be able to log into this. And in terms of your disk, right? As you know, we've already spoken about our encryption keys. So you can have Google managed encryption keys or your own encryption key for your disk. So with this, you can make sure that nobody else will be able to access anything in your machine. Since it's a virtual machine, it's isolated. So even though let's say two virtual machines are running on the same physical server, physical machine, they cannot see what the other machine is doing, or they won't have access to the same disk space. So that's how in terms of hardware security things are. So in terms of hardware, it's quite secure. In terms of software, you can set up firewall rules. So you can set up let's say SSH or HTTP or any of the other ports, right? You can set it up in such a way that only a particular range of IP can access that, or let's say a particular IP itself can access that, and so on and so. Or if you don't want to do any of that, you can keep all of your virtual machines just internal, and you can use one virtual machine to interact with all of the other virtual machines. So you have all of these options in terms of software. So this should be hosted. Since I changed this, so if I just refresh this here, yeah, it's what I wanted to host. So this is what I did. I just echo hello world, and I did that. So these are like very simple examples that I'm showing. I didn't want to get into any application development part of things. So LAMP stack is set up. Let me go back to my virtual machines itself. So you can see two virtual machines here. One was for the LAMP stack one. The other one was the simple HTML file that I just hosted and showed it to you. So I'll kill the LAMP stack one. So I'll show you another part here as well. So based on that, we can move forward. So let me create a new instance. let's deploy a container this time. Let's deploy an image as a container. So after you select the region, let's be 2% deploy container. So within the container, by default, it'll take a container optimized host image, host operating system, and here you'll have to put in uh, the path to your image. So you can store your Docker images either in Google Cloud itself, or you can directly host your image from Docker Hub itself. Let me host an Nginx Docker container. I'll not host anything. Let's just keep it to the page that is there by default. And I'll just go with Nginx Docker. So this is the image. It's named Nginx itself. If I'm not wrong, the path would be registry.hub.com/library/this. So what I want to do right now, right, and what I'm about to do is that I'm taking an image. This is not a virtual machine image. This is a Docker image. So as we've discussed, what containers are, this is just that. It's a Nginx image. So what you do with this is that you start from this. You copy your whatever files you want to host into the path of within the container, and you probably also copy the Nginx configuration for that, and then it's posted. That's what this image does. I'll send you the link of this as well, so you can have a look at that. Where is this? So yeah, this is the image. What I'm doing here is that I'm hosting this image. I'll give HTTP and HTTPS access. Let the rest of the things be the same. All right, create. Let me kill this as well. This will probably take some time because the VM is up, but the container should also be up. I'm not sure if I have access to it. Can one of you confirm if you're able to open this?
Yeah. Show me the Nginx welcome page.
All right, cool. So that was what it was supposed to show. So let's do something now. So I think I showed you how to create a machine image. From this machine image, I can create new instances as well. So I'll not do it. I'll just show it to you how to do it. So you can just like put in a name, put in where am I? Not the new machine image. So yeah, from this image, I can create new virtual machines. So if I click on create instance, I can put in the region and other details, and a new machine will be created. Let's not do that. Let's do something else. So let's look a bit towards scaling and how we can scale virtual machines. Yeah. So the same machine, right? You can actually like change the type or change the increase the disk size and stuff like those. So all of those things you can do. I'm going to show you something else. Let's create an image of the disk image of this, the Nginx VM that I just created. I'm sorry. And we will create an instance group. So what an instance group does is that based on the requirement, it'll spin up more it'll spin up more virtual machines. So based on whatever condition I given, it'll create more virtual machines that to let's say serve requests. So yeah, I will let me go inside. To do that, I will have to use use an instance template. Instance template is just defining whatever I put in during creation of the VM. Right, I just have to put the same details and create a template to use at a later state. But I cannot use a machine image there. I'll have to create a disk image itself. So disk image is similar to the Ubuntu image that I selected. So yeah. I will have to stop the instance first to do that. Otherwise, if there's any other file being written at the time, it will not preserve those changes. So once this happens, I will just create a disk image of the same disk that is being used for this, and then we will spin up an instance group for this. So normally what happens is that you do not create static IP addresses for your virtual machines. You create a template, you create an image out of your virtual machine, and you create an instance group. So after you create an instance group, you put a load balancer on top of that. So for that load balancer, you create a static IP address, and that load balancer will take care of, let's say, health checks to your instances, and like your instance group creating more instances based on your number of requests, and routing the requests to the particular virtual machines. All of these things will be taken care of by your load balancer. Let's do that, and probably we'll point our domain name to that load balancer itself. So I've stopped this instance, and I'll just get inside, and the boot disk. This is the disk. So I can edit this disk, and I can increase the size of this disk as well. So so you see something called as create image here. You have something called as create snapshot as well. These both, I mean, both look similar, both almost do the same things, but your snapshot cannot be used to create an image. What snapshot does is that it's layered. So if you create one snapshot now, the next snapshot that you create would be the other changes that you've done after that. So that's what a snapshot does to capture the changes. An image will, I mean, a single image will have the entire, virtual machine disk. So I'll just create an image out of this. Let me name this as Milan Nginx. The disk, the type of the disk where I want to store this, and yeah, that's pretty much it. Create. It'll take some time to create this. Any doubts till now?
I don't have any, but anyone else? Any doubts? If you have any doubts with anything so far, I can feel free to ask.
So we just got this. Yeah, the reason this might be a bit confusing is that we're configuring everything here. We've gone down to the infrastructure level, and we're doing all of these things. If you go just towards the platform level, and if you want to deploy things, it becomes very simple. So you don't have to do all of these things, any of these things, to be precise. But when you look at cloud, you will need to know how things work on the backend, right? So that is why we're configuring all of these things by hand. So my image is created, my image is ready. I'll just create an instance template for this. So if you're a bit confused about these things, you can just play around with things. You can create an image, you can create a template. You can always delete it. If things are not working at all, you can delete the entire project and create a new one. So you have all of that flexibility, and you also have $300 of credit, so nothing's limiting you to do anything. I'll just create a template. Yeah, let it be template 1, 2 cores, 4 GB RAM, and for the image, I will create. I will use the custom image that I have. Project this project. The disk image that I just created, right? I'll use that disk image, and I'll create an instance template. So let this be SSDs, and 10 GB is fine. I can't put this less than the disk image. If I put 5, I think, yeah, I'll tell you that you can't have it less than the original image. Allow these things, allow HTTP and HTTPS. Image is set, rest everything is set. I'll just create the instance template. It won't take much time because it's just configurations being set, nothing's being created. Yeah, it's done. So let's create an instance group from this. This is group 1. So I can select multiple zones here. or I can have a single zone. So if I put multiple zones, it will span across different zones within a single region. Let me do that. I'll just select Singapore, Asia, Southeast one. Instance template, this template, the one that I just created. And you can set up auto scaling properties here. Do you want to auto scale, or do you not want to scale, or do you just want to scale up and not down? You can set those things up here. And when do you want to scale? You can just put that. What this is doing right now is that it will scale up when your CPU utilization hits 60%. So whenever your CPU utilization goes above 60%, a new VM is created. That's what's set up. And whenever the usage comes below 60%, that is scaled. And the minimum number of instances and the maximum number of instances. Maximum, I'll just put this as 3.
When you set it to multiple regions, does that mean
Yeah,
that each
not
different
multiple
region,
regions, it's multiple zones.
multiple zones? Does
Yeah,
that mean that each different zone has a version of your code running on it, of your image running on it?
it depends. So if you have like 2 instances, right, and if each of them are running in different zones, then yes, you'll have a different VM running in different instances itself. I'm sorry,
Let's say
different zones itself.
one
Yeah.
instance, only one
Mhm.
instance, and it's not set to auto scale. And
It is not. It is set or it is not set to auto
it is
scale.
not set to auto scale. It does
Okay.
not
All
auto
right.
scale.
Okay.
And
Okay.
then I put it across multiple zones. What
How do
would
you
that?
put it across multiple? Like you'll replicate it manually, is it? You'll create multiple virtual machines and
Uh,
put it.
mm, yeah,
Uh,
how would I do that? Would I have to manually do it, or would I have to like?
no, you can the instance image that we created, right? So you can
Yeah.
just use that, or the instance template that we created, right? You can use the same template and you just change the region. I'm sorry, you just change the zone where you want to do it, and you create the instance. That
So I'll have to manually create multiple with the
yes,
same
yes.
template, multiple. Then
Template
what
will
is?
have everything configured.
Yeah.
You'll just have to change the zone in that case.
Okay. So there's no way which I can just using one single, how would I say it, one single instance group. I can have multiple zones.
I didn't get you. So let's say if you want to create, I mean, you mean a single zone, is it? You want to create multiple instances in a single zone. Is that
No,
what you're
no.
asking?
Right now we're making a instance group, right?
Yes.
Can I have the same instance group across multiple zones without having
Mhm.
to create it again? Or is
So
that
I will give you a couple of examples here, right? So let's say if I want to do it within a single zone, I click on single zone. The minimum I'll put it as 5. So 5 instances will be created. Yeah, 5 instances will be created within the single zone, whatever zone I select here of the same application. If I let's say put multiple zones and I have 5 minimum instances, these 5 will be spread across the zones within this region. So you might have different zones within a particular region. So let's say Singapore might have 3 zones and US Central might have 6 zones. So depending on how many of zones you have, it'll be created within those zones. So that's how these things are divided. Yeah. Did that answer your question? I think what you meant to ask was you wanted to create multiple instances of the same image and not do it manually. Is that what you wanted to know?
yeah, that's what I kind of wanted to say.
Yeah. So just put this as 5. So 5 and 5. So it will only create 5 and it will not scale up, it will not scale down. Turn off auto scaling. It does not matter what you put here because maximum minimum are 5. It will create 5 instances and depending on wherever you put it. Let me just do this. Asia, Singapore. B, the template 60%. I will go with 1, or let me go with 2 and 3. So we have a quota for any region for virtual machines, right? Your virtual CPUs, you can have 8 virtual CPUs in a particular region. That is your quota. So I can't go above 8 in the free tier. So 2 into 3 would be 6, and the in the instance template I have chosen the image to have and the machine to have 2 virtual CPUs. So that brings it to 6, even at the maximum case.
Okay, that makes sense. Thanks.
So 2 and 3, these are just a couple of other options. Health check. for health check, right, you can do a couple of things. I can use HTTP to do it. I can, what this would do is, in periodic intervals of time, I can set the intervals as well. It'll send a request to port 80. I don't need any path, and path/path, and check if it gets a response. Even if it gets a 404 response, it's considered to be working. So just to make sure that your instance is running, this is how you do a health check. So periodically, uh, so check interval is 10 seconds. So every 10 seconds, this will send a request, HTTP request to port 80 of this of the instance to check if it's running or not. Let's put this as health C1. Okay. Yeah, 2 and 3 maximum. All right, everything else is fine. I'm just creating the instance group now. So once you have this instance group, depending on the traffic coming in, it will scale. So as I put minimum to be 2, you will have 2 instances running at any time. And if you have more, if your CPU utilization in both of the VMs go above 60%, then a third one will spun up from the same image. So that is what I've configured this to do. So yeah, by the time this happens, let me go create a load balancer as well for this. So within your network services, you will find this load balancing. If you click on that, you can create a load balancer. So you have a couple of options. We'll go with HTTPS load balancer. If you want to have this load balancer between your virtual machines, or if you want to have it, put it between the internet and your virtual machines, you can select them here. So the name is LP1. The backend configuration. I hope it is. Let me configure the front end before all of that. So the networking, the port, the IP address. I can create a static IP address here. I will put this as LB1. I'm reserving a static public IP address for this load balancer. Yeah, I've got the IP address and the front end service. I configured the front end. I hope the instance group was created. Yeah, it is created. All right. So backend, I'll configure it to be the backend. So I have to create a backend service pointing it to the backend. I'm sorry, the instance group. So I'll just create this as a backend one. Instance group, and the timeout instance group is this one. Port number is 80. Balance based on utilization or rate. So if I put in rate, so if 10 requests comes in and I have 2 instances, 5 will go to the first instance, the other 5 requests will go to the second instance. So if I go with CPU utilization, so based on the utilization, whichever has the lower utilization of the CPU, the request will be routed to that. I'll just go with utilization, and yeah, done. So if you want to enable CDN, you can do that here. Health checks. I've created one health check. I'll use the same health check. And yeah, great. So your backend is done. Your host path rules is done. So what this basically does is that you can specify certain routes as well. So if you have like multiple backends, multiple instance groups, you can specify a particular path, and that path will go to a particular instance group. You have those options as well, but by default, it's like unmatched. Whatever is not matched will go to this. So that's what I've left it with. Reviewing what all I have. So it's just checking for the backend. So I can create it, even when this is happening as well. Let me go ahead and do that so that I can point my domain name to this as well. Load balancers usually take a bit of time to be up and be configured. Let that happen. In the meantime, I will point my domain, the one that I registered right now, to this IP address. So for all IP addresses, external IP addresses, you can find them here, and you can see where they're attached as well. So yeah, this is the one for my load balancer, the one that I created for the load balancer. This is not used. Whatever is not used, I can just release them. So if I don't release them, I'll be charged for reserving a static IP address and not using them. So since this is the static IP address, I'll show you how DNS works. So this is where I registered the domain. So I'll go with manage the domain. So in DNS, right, you have these things called as name servers. So they're like the top level ones. So when you get them, when you register a domain, they will be with your domain provider itself, but you can change them to something else. You can change them to, let's say, Cloudflare's DNS or any other provider who provides name servers. So once you do that, your name servers is actually where you actually put in your records. So to point some domain name to something, you'll have to create these records. So against a domain name, you can request for records. You can have different kinds of records. You have like alias records, you have CNAME, you have text record, and MX is for email addresses. So if I create a text record against this, whenever somebody queries for the text record from the domain, it'll return whatever I've put in here. Alias record is where you point a domain name to an IP address. So whenever somebody goes to the browser and types in a domain name, it'll request the domain service that is configured, and that domain service will ultimately go to your, let's say, top level domain, and it will ultimately reach your name server domain name server, and it'll get that IP address. And these IP addresses are cached in these domain name servers. At each level, these things are cached. So once, if you go one level up and you've got a response, the next time that you go or somebody else goes to that domain name server itself, it will not request the higher level of domain name servers, because these things will be cached. So you get that response. If I change that to a CNAME record, you can point one domain name to another domain name. So at times you can get something like some providers will not give you an IP address, because that IP address will be shared among different applications or different users. They'll give you a subdomain, something.something.com, and you would want to point your own domain to that. So for example, let's say if you're using WordPress or Heroku or any other service, they would give you let's say your username dot or your application name dot their domain name.com. So you can use CNAME to point your domain to that. So let me just put this as a record itself, and this is where I want to go. So if I want to have some subdomain here, let's say something.nis and milan-nisb.in, I can have that here as well. I can put that record here and make that point to something else. So I think 300 works. So the time to live, this field, I mean, in DNS, what this means is that this confirms that for this 300 seconds duration, this record will not change. So that also means that only after 300 seconds will this record be updated in all of the domain name servers. So the recommendation is that you keep it lower the first time that you create it. After you create it and it's updated everywhere, you put a higher number. So the domain name servers at different levels, right? They won't send another request for that duration of time. So if you keep it, let's say, 1 day or 1 week, within that week, the cache will not expire. So you don't have to query this FreeNorms DNS server at that duration. Yeah, so I have updated this, and I'm not sure if I have to put an @ here. It depends on different providers, but I think this would work. This will probably take about 5 minutes to be updated everywhere. Until then, let me just check my load balancer itself if this has started working. It says my backend is not responding. Okay. Okay, I've not cached it, that's all. So can someone confirm if this address is working for you? I'm not sure my machine will be able to hit it, my policy.
I'm getting a 404 on that.
Yeah, then it'll take about 5 more minutes to be set up. So the load balancer will have to set up things, right? So how things works is that you're not actually hitting that machine. Whenever you put in this address, you're hitting the closest Google's front end server that you have, and from that front end server, everything else is routed. So your IP address networking, right? The address that you put in and stuff, it'll end at either the first load balancer or the second load balancer internally that we have. After that, everything runs through gRPCs. So your IP networking kind of ends there, and from this IP address, you're right now hitting the Google front end, but the front end is not able to reach the back end yet. It'll take some time for that to be configured. You can see this loading here, right? It'll show you a green tick mark here. Once that happens, everything's been set up, and all your scaling and everything works. And I've also pointed my domain name to this address. So 300 seconds is 5 minutes. So within 5 minutes, this domain should be pointing to this instance group that we have. So the process remains the same if you're getting a domain from, let's say, GoDaddy.com or any of the other providers. So you can get something like your name.com or any of these things. And for students, you actually can use GitHub Education. With GitHub Education, you have a couple of providers who are giving premium domains for free for students for 1 year. So you could use that as well, get domain names. Please refresh this and check once. It says backend service unhealthy. Let me just check my backend service.
Does that mean there's something wrong with the deployment, or?
We don't know. So we can check that here. Instance groups. So if I can hit this image, right? If I can hit this virtual machine itself. So we're getting timeout for health checks, which means that we're not able to get a response within the duration that we put in from these instances. I'm not sure if I can open this. Check. Can you check this? Can one of you check if you're able to reach this?
It's stuck in an infinite load cycle. It's not resolving.
Then probably there might be something to do with my code or the image itself that I've put in. So let me see if I can do something. But either way, that's how you do things here.
Does this give us
So
like logs or whatever?
Yes.
Instance logs?
You do get logs. Yes. So you have like different kinds of logs that you can check. So you can just go down here and see within logging. You can just click on logging and you can select, let's say, if you want to see, let's say, logs from, just check logs here itself. Or if you can select a particular virtual machine instance itself and do the things. So let me go with, I want to see what is happening within the virtual machine. The logs of the virtual machines is something I want to know. So I think it should be compute engine GC VM instance. So these are the instance group images. Let's go with one. Let's see what logs we have. Also, you can SSH to the VM instance itself and check the logs there, wherever it's written. These are just operational logs. So we don't have the Nginx logs shown here. I'm not sure if we're actually hitting the service.
Maybe it hasn't reached the edge servers yet.
It might take some time to configure, but the virtual machine itself, right? So let me check if the virtual machine itself is working first within the instance group. With that, because I'm not sure of things, because I did not build these things. I've just taken this as an image from somewhere, and I've replicated this part. So also, as I mentioned, I just took I just created an image of another virtual machine that was there. There might be some mistakes there as well. The machine might probably not be in the state where it was running this. So if this is running, if this returns the Nginx page, welcome page, then it means there's some configuration mistake within load balancer or instance group and stuff. If not, it would mean that there's a problem with the image itself. Are you able to hit this?
I I don't think it's gonna eat this one either.
So yeah, so in basic terms, that would mean the image that I created, right? This image, there's some fault with this disk image. I'll have to recreate it. This Milan dash Nginx one. I'll have to check whatever mistakes that I've done, and I have to recreate this. But it is okay. Let's not do that. Uh, how much time do we have? We have half an hour. I will try to do something else. I'll just try to create an, or I'll try to SSH into it. In the meantime, do you want to also know about App Engine, how to deploy to App Engine?
I think yeah, I would we would like that, but I think it's better if you try figuring how to fix this, because in my experience, whenever I am deploying to the cloud, I usually get some kind of error here or there, and I'm usually lost in
Okay,
how
all
to
right.
fix it out. That's why.
So let me check the services. Okay, CPU percentage is 0 almost. There's something wrong with the container. So Docker is the command that you use to interact with Docker images. Here it says this is up, and let me try to do a curl to this. There might be a problem with the port itself. I'm not sure if I expose the port for this container. Let me see if I can check that. It's got to be right. Let me just attach to it and check. I will probably have to check this image itself. Yeah, Pranav. So
Oh, that's fine. Then we can move on. No worries. I was just
so this will take a bit more time.
yeah.
So
I understand that now.
I think it's from what I understand, it probably might be the port mapping itself. So Docker images here runs on the host networking, and I'm not sure if the port is exposed properly. To investigate that, I'll have to run this as a normal image. I'm sorry, start a normal VM instance with that container from Docker Hub, and check how things are running there, and then create an instance image from that. So that will probably take some more time to investigate. So, yeah, if this is not hitting this, yeah, there's probably some issues with the instance image itself. So I'll have to redo that. It'll probably take about half an hour. It's okay. So you've understood how to do the load balancer part, right? The instance itself. So I understand there might be some issues with the image itself of Nginx that I installed, or the way that I've started the instance of that. So yeah, we'll figure that out later. So in this time, let's move to the app engine itself. So till now we configured everything, right? So all of the infrastructure was configured by us, and we had to do a lot of things. Most of the things were confusing, and it was too much to do. So app engine, you don't have to do any of that. So I will just demonstrate hosting a Python application here. So one thing to note is that you can only select the region of your app engine once. You can't change your region in a particular project. You'll have to create a new project itself. So let me go with this how to. You can change the environment and the runtime for this. So App Engine has two things, right? One is your standard, and the other one is Flex. Standard, basically, what it does is that you're limited by a couple of things, but all you have to tell it is the runtime that you want. Let's say Python 3.8 or Python 2.7, or let's say PHP or anything, and you write your code. So it has a couple of requirements. Let's say for Python, your file name should be main.py, and a couple of other things. But you can pretty much do the same thing here. You don't have to do anything else, and it'll auto scale based on how you put things up. So let me just open up a Python application, and I'll just show it to you. I think within the Flask, I have this app. It should run on port 8080. Don't worry about this. Yeah, your application has to run on port 8080 for your app engine, and it'll route it accordingly. So I'm just returning hello world, nothing else, nothing fancy. One other thing that you would need, yeah, the things that I missed here, you need a requirements.txt file. I'll generate that. So right. Uh, for App Engine, the only extra file that you need apart from your application itself, right, is your app.yml file. So this is where you mention, let's say, the configuration for your App Engine. So you have, applications, deployed in terms of services here. You can have a default service, and you can have different other services with your App Engine default service. So you can mention the service name here. If it's default, you don't have to put anything. Uh, so the only thing that I have to put in here is runtime. I'm going with Python 3.8 runtime, and app file should be named as main.py. And let me open this in my terminal. I need the requirements.txt file. I'm just creating a virtual environment here, and I just install and check if the application works locally. Let me just check if it's working. Okay, it's running on port 80. I don't think I saved that. Let me just check this one more time. I think there's some issue with my virtual environment. So it's okay. This will work. I'll just deploy this. It's not saving. So let me just check why this is not saving. Yeah, it's just saved. So right. Yeah, I have my requirements.txt file, my main Python file, and the YAML file for my app engine. So if you want to check them out, this is the YAML file, the main, the Python file, and my requirements file. All right. To deploy, all you have to do is type in gcloud app deploy, but I've not set up the gcloud here yet. I can show that to you as well, or I can move these files to the console here. Let me do that itself instead of doing it locally. You don't have to do it locally. So I'm in this directory, and I have the three files required, and I will do gcloud app deploy. So it'll just ask you to confirm things. So this is the YAML file, the source, the target project, the service, and that's about it. This is the endpoint that we will have. So you didn't have to configure anything here. Once it's deployed, I can also show you how traffic is routed. So you can do it in such a way that you'll have one version running, and the later upgrades that you have, right, the newer versions that comes in, you can have incremental upgrades. You can split your traffic. You can let's say deploy it without any traffic being routed to it, and then let's say route only 10% of the traffic, check out how things work, and then increase that routing to 20%, 30%, 50%, and then 100%. So you have all of those options here if you want to have like an incremental update to be rolled out. So this I think takes about 2-3 minutes.
Is that similar to the older instance and the newer instance thing you were talking about earlier?
Which older instances again?
During the beginning you were talking something about we can create multiple instances where one will be an older one, then the other will be a newer one, and you
I
can
think
have
that
push
was
updates to the
I think that was towards the SQL part of things.
yeah,
So
yeah.
whenever security updates comes in, if you choose an earlier channel, that is only for like maintenance of SQL. This is different. This is where you can deploy your application to different services, and you'll have different endpoints for these. So you can have different versions of this, and each version you can, like, let's say standard one, everything is deployed. So even if you don't have a container running at the time, so this is done right now. So if I just go to this endpoint, it should be hosted. Yeah, it's done. So if there are multiple requests coming in and this container cannot handle that, it'll scale up, and it'll scale up within a second. So in the fraction of a second, you can have multiple containers spin up. So if I go back to my this thing, right, the app engine, let me refresh this. Close this and refresh that. So you can see this is service in the versioning there. So you can also look at traffic there. So here we didn't do anything. We just went into our our application folder, whatever we built locally. I just created an app.yml file and I put the runtime. This is for standard, right? So in standard, your application can scale down to 0. So if that's one advantage that you have, because you won't be charged for running something when there are no requests. So yeah, if I come down to versions, right? So this is one version that we have, and it's serving 100% of traffic. So I can create another version and I can allocate traffic how much ever I want according to my requirements. So when I say incremental updates, that's what we mean when we deploy a new version. We want to, let's say, roll it out to only certain people. So let's say 10% of the people coming in, right? They will look at the new version that's out there. And based on the response that you get from them, then you can probably roll it out to the rest of the 100% of people. So that's how you do things here. So if I were to roll out a newer version, right? Let me do it from the shell. I will change this to something else. Instead of hello world, let me put this hello everyone. It's for the sake of demonstration. So I will deploy this again. If you want to provide a version name, you can do it by putting a -v flag. I'll put this as version 2. Yes. So yeah, this will again create a new version and deploy the service. If you want to have a different service, you can put the service name in your app.yml file. It will create another service. So that service would have a different endpoint than your default service. This will happen within like 2 minutes. So this does not take much time, but yeah, the other variant of App Engine is Flex. So the standard one what standard does is that App Engine standard, it will take your code, it will upload it to your cloud storage bucket. It will create a new bucket and it will upload it there. It will run a cloud build on that. So it will send a configuration to cloud build to run an image out of this container or out of your code. It will upload that image to your container registry in Google Cloud, and then it will spin up a container of this. So that is what App Engine is doing for your standard. For the Flex, right? Flex, you get more flexibility. So you can choose to use languages that are not supported by standard. You could do a lot more things. Yeah, it's deployed. So if I refresh this, I'll be able to see that, and I'll be serving 100% of the traffic. So to check the older one, I can just click on this. If there are no containers running, it'll spin it up immediately and it'll route the traffic. So for me to split the traffic, I can just select split traffic, and I can add whatever version I want, and I can select how much ever I want to split the traffic. So right now, for the sake of demonstration, I'm splitting it randomly, and then I'm putting 50% allocation. So it's done. So if I check the versions, right, when you click on each individual versions here, it will still show you the same version, whatever you selected. But if you go to the endpoint itself, the default one of this, so it's showing me hello world. If I keep refreshing, at some point it should show me hello everyone. Yeah, hello everyone, and let me refresh again. Hello world. So yeah, after time it shows me one version, the other half time it shows me another version because I put 50% split in traffic. So that is about the App Engine standard. Your App Engine Flex, the container that we have, right? So you will have the environment that we have. For Flex, you again have a couple of images that you can choose, the the runtime, and you will be able to SSH into it. So the way that runs is that it will create a virtual machine in your project and it will run that as a container inside the virtual machine in your project. So it'll be one image per virtual machine in your project. That's how App Engine Flex works. App Engine Standard just runs your container in Google's infrastructure. So it does not run, it does not create a virtual machine separately for you. It does not run that container within a virtual machine in your project. So because it does it that way, it's very easy and it's very fast for it to start a new container. So even if this version is not running, any of the versions are not actively serving requests or has zero instances. Currently, it shows zero instances for this version here. But even if I click on this version, uh, yeah, it just created a new container and it served the traffic from that. So it takes less than a second to do all of that. That's about App Engine. We've got about 10 minutes left. Any doubts? Let me move on to doubts now. So, yeah.
One doubt I had was
Yeah.
why would you want your container running inside Google's infrastructure? The last part you said.
Okay.
Would that not make it less flexible?
No, when I say Google's infrastructure, yeah, that's the reason. This is a platform as a service offering. This is not an infrastructure as a service offering.
Oh.
So that is the reason you are not selecting a virtual machine. You are not configuring things here. So Google manages all of that for you. You manage your dependencies and your application code.
Okay, that makes sense. Okay.
Yeah, there's also another option here. When I said Flex, right? So in
Hmm.
Flex, since it's running in your virtual machine, you can SSH into it, but you're still using the runtime from Google itself, whatever, let's say Python 3.8 or any of these things. But if you want to run on your custom runtime, you can still do that. You can create a Docker image. You'll just have to provide a Docker file with this. So the application code, right? So within this folder, with these three files, you'll also have to have a Docker file. So there you can specify how your image should work. So that in that case, your App Engine will actually take a Docker file and create a Docker image out of that, and then use that to create containers. And even that runs within a separate virtual machine in your project. So
Okay.
standard takes, let's say you just saw standard take about 2 minutes to run, right? Your Flex will probably take about 10 to 15 minutes to start up because it has to do all of that. Yeah.
Okay, that makes sense. Yeah.
And there's one more option after this. So I am not sure if you have time to look into that. So we have Cloud Run and this Kubernetes engine. So what Cloud Run does is that it just picks up a Docker image from your container registry and it runs it in Google's infrastructure. That's all Cloud Run does. So in a way, you can think of, let's say, App Engine standard to run on Cloud Run itself. So after doing all of the image building and uploading to the right places, running that could, it's similar to running it on the Cloud Run. So I can demonstrate this quickly. Let me do that for you. So I'll use the same image, this Nginx image itself. Uh, I can't directly use the image from the Docker Hub for Cloud Run. I'll have to store it in container registry itself. To do that, I will just have to pull the image, Docker pull. This will pull the image. The thing about Docker is that everything's layered. So if another application is using Nginx itself, it will not pull it from Docker. It'll just use the one that you have. Next, I'll have to tag this to the container registry's endpoint. Docker. So for container registry in GCP, you have a couple of options. This means it's Asia. If you want to like a generic one, you can use gcr.io itself / your project ID. Sorry, I did not copy my project ID. It should be Milan. Project ID / the name of the image that you want to put in the container registry. I'll just keep this as Nginx itself. MS something. So Docker tag the image name that you have locally, and the remote. It's done. Now I will have to push this. This is a bit out of scope of GCP. It's more to do with Dockers. But like it just takes a couple of seconds to do this. So let me just do it. So it's done. So I just took this image from Docker up and I put it in my project in the Dockers in the container registry. You can check that here. You go to container registry. Yeah. It shows you the images. As I mentioned, this is your functions. Whatever we did in functions, it's stored as a container here. And the app engine part, whatever we deployed with app engine, is shown here. And this is the new one that I just uploaded, just pushed to the container registry. This is the container. And with Cloud Run, I can create a service and deploy that. This will enable the API. Service name, I just put this as Nginx itself. Ultimately, when we talk about this itself, right, the container registry, it's just a representation showing you where you have your images. Ultimately, it's stored in your GCS bucket itself. So if I go to cloud storage, it will show me all of that. So it is stored there. Region, let me go with Singapore. Service name Nginx. First division. What I can do here is that I can have continuous deployment. So if I have a Docker file and I can have it in such a way that I push to GitHub, and as soon as I there's a commit or pull request being merged to my to a particular branch on GitHub, this process would start. So this would build a new image, it'll upload that to the container registry, and then it'll spin that up. So you can do that as well. Now let me just select the image that I have, Nginx, and the latest one. So yeah, this will deploy that. You have a couple of options. You can specify the port. Since this runs on port 80, I'll just put that as port 80. And you can have a couple of other environment variables and stuff. So in Python, let's say in your application, right, if you're connecting to some other service, let's say a database itself, SQL server, you can't put your credentials in code. Right, you can't put your credentials there or any kind of authentication in code and deploy that to push that to GitHub or any other place. So you can use like environment variables here. So in your code, you can read that environment variable, right? So if I said something like MySQL host or MySQL password, you can read that in Python, and you can set the same thing here as variables. You can just add whatever a name you have and the value here, and it'll use that. So that's how you can authenticate with your other services. So the memory that I want, CPU allocated, request timeout, and scaling from 0 to how much ever I want to scale. So between these, it'll scale by the number of requests that comes in. So I've put 80 requests per container. So if I get 81 requests at any time, it will spin up a new container. So that's what Cloud Run does. Environment variables, just delete this. So if I want to allow unauthenticated invocations, or does it require authentication? And I just create this, and it will create a service, and it will run that image as a container, and it scales up. Scaling a container is very easy. I mean, if things are right within the same architecture, right? Scaling it up can happen within a second. So this will take a couple of minutes. But in the meantime, any questions that you've had so far? Just to sum things up, we looked at some theory about cloud in the beginning. Then we looked at the cloud storage. We looked at SQL. We looked at cloud functions. We looked at VPCs. We looked at the compute engine in GCP, instance groups, instance templates, and load balancing in GCP. After that, we looked at the app engine to deploy applications. Now we're deploying uh, an image container on the Cloud Run service. So it gave me an endpoint. If I click on this endpoint, I'll be able to visit that image. So this is a container that's spun up. And this again scales down to 0 when I don't have any requests coming in. And I think that is it from my end. Any questions so far?
If it scales down to zero, would that not cause any problems?
You'll have a lazy start for the next
Yeah,
request that comes
would
in.
that would not
You can, yeah,
it cause a cold
there
start,
is,
right?
yeah. So there will be a cold start, but in terms of your application, right? Like it won't be for a longer time. So if you have a very big application, if it takes a lot of time to do it, you can specify the configuration itself to state that after how much time, let's say after you have no request, that it should scale down to 0. Or if you don't want to do any of that at all, you can specify the minimum container. No, instead of putting it to 0, you can put some number there. So many containers will be up, even though you have no requests coming in. So it all goes around how you have your application and what type of application that is and how much time you would need for that cold start. You can test it out. You can test out a cold start and see how much time it would take for a container to spin up. In most cases, within a second, so it shouldn't be much of a problem. But if that is like a limitation, you can put at least one as the minimum number of containers for scaling.
Yeah, I think that,
Any
yeah, that
other
makes sense.
questions?
Not from my end. Anyone else?
Case, okay, this is just a slide to information about how to contact me in case you have any other doubts or if you want to reach out to me for any reason. And feel free to reach out to me. Like, I do know like people tend to hesitate. They would think like people are busy and stuff. I might be busy, but I will respond back whenever I'm free. So I mean, I'm giving an open invitation. You can contact me anytime. So yeah, thank you. That's about it.
Okay, Milan, thanks for the. You took 3 hours long. I don't know how I would have managed 3 hours worth of information that time.
So it is kind of weird because it's remote, right? So you can't actually
Yeah.
go there and see if people are actually getting it or if they're facing issues. Because most time people don't speak up, so it is quite
Yeah.
new.
Hopefully, when things get better, we love to have you
Yeah,
over back in Mysore and then have a hands-on session in real life.
yeah, sure.
So yeah. So thanks for today's event. I really learned a lot. I had a lot of doubts with cloud because that's some things I usually struggle with. But most of them, if not all, are kind of cleared enough that I can work with it now. So thanks for that. And yeah, that is it from my end.
Yeah, thank you for having me here. And I do know that this was an introduction to cloud, so we didn't go in depth with any of the products, but we just scratched the surface of most of the things that you would like probably use if you're getting into cloud. But yeah, so in cloud itself, a lot of things are new. So what we have today, we might not have tomorrow, and we might have a lot of new things that comes up tomorrow. So things are like moving, rapidly here, and yeah, I hope this was like helpful to people who are getting into cloud. So if you want to like dig deep into things with let's say containers and stuff, you could look at Dockers and you could look at these solutions. You could look at Kubernetes itself. It's very trending right now, and a lot of enterprises are getting into Kubernetes. So you could explore more towards Kubernetes. And yeah, that's about it.
That's interesting. Maybe in the future we can do that.
Okay, thanks, Aina. Have a great day.